Happy morning, students. Let us see the zeolite. Today is the last topic in this lesson. Zeolite are 3D crystalline solid containing aluminum, silicon and oxygen in the regular 3D, that is 3D dimensional framework. What are zeolite contain? What are the elements is there? Aluminum, silicon and oxygen. Zeolite is a crystalline solid. Okay. They are hydrated, so it contains water molecules. Hydrate means it contains water. Anhydrate means without water molecules. They are hydrated sodium aluminosilicate. So zeolite is sodium aluminum silicate. The general formula of zeolite is NaO dot Al2O3 aluminum oxide and X moles of SiO2 and Y moles of water, where X, the silica means X is equal to 2 to 10 will be varying. So Y, water molecules is 2 to 6. This is the general formula of zeolite. Zeolite have a porous structure. It have the porous in which monovalent sodium ion. Monovalent means contain Na plus ion and water molecules are loosely bound. So it's a zeolite is porous structure. So monovalent in which the porous structure in which they lack monovalent sodium ion, that is Na plus, and water molecules are loosely held. Silicon and aluminum atoms are tetrahedrally coordinate with each other through the shared oxygen atom. How it is? Now write a silicon Si. Here is O minus. So this is the structure. Silicon and aluminum atoms are tetrahedral coordinate with each other through shared oxygen atom. Zeolite are similar to clay material. It's similar to like a clay material. This also zeolite also similar to clay material, but differ in the crystal because zeolites are crystalline solid. We already see zeolites are crystalline solid. Clay means it's packed. Water molecules are consumed heavily. Okay, but zeolite water molecules are loosely bonded. Zeolite have a 3D crystal structure look like a honeycomb. How the honeycomb look like? Same thing for 3D structures. So look like a honeycomb. It's considered a network of interconnected tunnels and cages. Look like a cages. Water molecules move freely in and out of this pores. So it's a porous structure. Means the water molecules are loosely bonded. It will freely move in and out of this pore. But zeolite framework remain rigid. It's a rigid structure. Very important aspect in the zeolite means the structure is that pore or channel size are uniform. It will be uniform structure, allowing the crystal to act as a molecular sieve. Jallada madri, like a jallada. The zeolite are used in the removal of permanent oddness of water. It removes the oddness of water. Permanently it removes all the salt water. Okay, so after this this lesson is finished. We'll go through this also. Do you know the given boron neutron capture therapy? So we'll see that this is treatment for brain tumor. Let me see this one. The affinity of boron 10 for neutron is the basis of technique is known as a boron neutron capture therapy for treating the patient suffering from brain tumor. So BNCT treatment is given for the brain tumor. It is based on the nuclear reaction that occur when boron 10 is irritated. It will irritate with low energy. Boron 10 irritated by low energy thermal neutron. Neutron charge is 1, mass is 1, no charge is there. It gives the high linear energy of alpha particle. Helium, alpha particle means helium, 4, 2. Then lithium particle. Now write here. How many mass boron is 10? Neutron is 1. Totally 11. Now count here. 7 plus 4, 11. Boron is 5. Neutron is 0. 5 plus 0, 5. Here is 3 plus 2, 5. So both the sides are equal. You must add mass and find out. The mass is equal, the mass in the reactants is equal to mass in the product side. Atomic number, count and see the atomic number here also. The boron compound are injected into the patient. So you're going to inject them. So boron compounds are injected to patient with brain tumor. Those having brain tumor, they're going to inject this therapy. So boron 10, and the compound is preferably in tumor. Tumor, which part is tumor? Any affected part is irritated with thermal neutron. So that is so thermal neutron will irritate, release. If irritate, they'll release what? They'll release alpha particle. So this alpha particle that damage the tissue of the tumor, damage the tissue in the tumor. Each time a boron 10 nuclei capture the neutron. So then if every time, so we are affected place, if a neutron is released, they irritate with thermal neutron. They release the alpha particle. What they release? Alpha. That damage the tissue in the tumor. Each time a boron 10 nucleus capture the neutron. So boron 10, the nucleus inside the nucleus, it capture the neutron. In this way, damage can be limited preferentially to the tumor and leaving the normal brain tissue less affected. They not affected the normal tissue. Only damaged tissue only, it will purify this while applying this therapy. BNCT has also been studied as a treatment for several other tumor in head, neck, breast, prostate, bladder and liver. This is called BNC therapy. Okay, this part you must go through all the You want to score more mark, you must go through everything, each and everything in this textbook. Then question bank, they given complete the following reaction. They all given the reaction, all and this one reaction is given. What are the reactions? But you must find out the product. Okay, what is this? BOH thrice is boric acid react with ammonium. If boron react with nitrogen, it gives a boron nitrate. Remain 3OH, here is H3, 3H2. Now this is borax, Na2B4O7. React with sulfuric acid and water. The sodium react with sulfate, gives a sodium sulfate, and remaining is boric orthoboric acid or boric acid. B2H6 is diborane. React with sodium hydroxide and water. It gives a sodium metaborate and hydrogen. Diborane react with methyl alcohol. What is the CH3OH is methyl alcohol or methanol. It gives trimethoxyborate. CH3O is a methoxy. So how many methoxy is there? 3. Trimethoxyborane and 6H2. Now take the BF3. What is BF3? Boron trifluoride. React with water. It gives boric acid, hydrofluoro. HBF4 is hydrofluoroboric acid. Now formic acid or methanoic acid react with sulfuric acid. This is a dehydrating agent. Sulfuric acid is act as a dehydrating agent. It's remove the water molecules. If you remove the water molecule, H2O, the remaining is carbon monoxide. The carbon monoxide, water and H2SO4. Now silicon tetrachloride react with ammonia. Take the 3 moles of silicon tetra, 2 moles of silicon tetrachloride. Now write Cl3, Cl, split 1 chlorine, and ammonia is NHH. Then write again Cl3 Si. Now remove HCl here. Now your product is, write NH first. The nitrogen liquid silicon SiCl3, here also SiCl3. That is, what is this? Chlorosiloxane. Then silicon tetrachloride react with methanol. How many chlorine is there? 4. Write 4 methanol. Now remove this one. Remove 4 hydrogen. 4 hydrogen combined with 4 chlorine gives 4 HCl. The remaining is tetraethoxy. C2H5O is ethoxysilane. Then boron react with sodium hydroxide. It gives a sodium borate and hydrogen. Sodium borate and hydrogen. Right here 6 moles. Now what is this? And this H2B4O7. This boric, this is one kind of boric. I'm eating red heart. It gives boric anhydride and water. Complete the following reaction. So I given all the answer in this part. The reactant part only they given. So I wrote here all this answer. Go through it. Okay. Then next. Now see the evolution part. In multiple, choose the correct answer. An aqueous solution of borax is it's a basic. Boric acid is an acid because its molecule boric acid says because it accept the OH minus from water and releasing the proton. So it accept the OH minus from water and releasing the proton, that is H plus. Which among the following is not a borane? B3H6 is not a borane. Which of the following metal has the largest abundance in the earth crust? That is aluminium. In diborane, the number of electrons that account for banana bond. How many banana bond is there? 2 electron. Here also 2 electron. 1 electron from p orbital boron. Then 1 is from hydrogen. Here also 1 and 1 from hydrogen. So 2 plus 2, 4. The element that does not show the catenation among the following P block elements. This is group 14. This is also group 14. Germany also group. So lead, the lead does not show the catenation among the following P block. So lead one won't show. Carbon atom in the fluorine with the formula C60 have sp2 hybridized. Oxygen state of carbon in the hydride is +4. The basic structure unit of silicate, what is this? SiO4 4 minus. The repeating unit in silicon is silicon. Like the alkyl group, it will continue. So this is a repeating unit of silicons. Which of this is not a monomer for the high molecular mass silicon polymer? Means not a monomer. These are all monomers. See here, PH, Me, this is aromatic, methyl, this is dimethyl. So which is not a monomer means Ma3 trimethyl SiCl. Which of the following is not sp2 hybridized means dry ice? Geometry in which carbon atom and diamonds are bonded to each other is tetrahedral. All linked with tetrahedral. Which of the following statement is not true? Feldspar is not an aluminosilicate. AlF3 is soluble in HF only in presence of Kf. This is due to the formation of the AlF3 react with HF, Kf react with Kf in soluble in HF and only in presence of Kf. Now it forms how many K is there? 3, right? 3 K3. Here is AlF6. How to name this means potassium hexafluoridoaluminate. Hexafluoridoaluminate 3 ions. Okay. What is this? Again repeat this one. Potassium. This is cation. Hexafluorido. First must name the ligands. How many ligands is 6? Hexafluorido. This is a anionic complex because this is cation. This is anion. So this is aluminate 3 ions. Okay. Then match the following. You see here borosol B3N3H6, boric acid BOH3, quartz SiO2, borax Na2 B O5 OH4 8H2O. Again repeat this one. Borosol B3N3H6, boric acid BOH thrice, quartz SiO2, borax Na2 B4O5 OH4 times 8H2O, 8 octahydrate. Duraluminum is an alloy of aluminum, copper, manganese, magnesium. Thermodynamically, the most stable form of carbon is graphite. The compound that is used in the nuclear reactor as a protective shield and control rod is metal boride. The stability of +1 oxidation is increase in the sequence. Aluminium is lesser than gallium, lesser than indium, lesser than thallium. Okay. That's all for this is for all the choose. I go through it everything. You must go through all this lesson, first lesson and second lesson. I completed first and second lesson in the inorganic chemistry. The next class we will see the physical chemistry. Okay, physical chemistry, solid state. Thank you, students.